All right, so Unity, the game engine, the myth, the legend. Just kidding. It's not a myth. It's real. Unity's great. It sits kind of in between Game Maker, in my perspective, between Game Maker and Unreal in terms of its sort of capabilities and the features that it offers. It's certainly more adaptable and fully featured than Game Maker is. Game Maker is very specifically a 2D game engine built for building games. Unity, you can build games, apps, museum, interactive experiences, VR, immersive things. You can do cinematics and more. Unreal, I would say, is more designed as a well, they brand it like this. It's for epic games, right? It's for games that are that have big teams and hundreds or thousands of assets, and potentially networking and stuff like that. AAA, right? And this actually does have kind of a big impact in how you use an engine, because when you step into Unreal, a lot of the architecture of the game and the way systems are set up and operate and communicate is done for you, and it's done by smart people who know what they're doing. But it does kind of shoehorn you into a bit of a certain type of game, which is those AAA titles. Not to say you can't sort of adapt it to do your own thing. Certainly, architects have been using it for its rendering ability. The car industry has started using it even. But Unity is like a blank slate. It's like a blank canvas. And that's good and bad. It means that you have to do a little more setup work and, adapt it to fit your style of game that you're building. But it means that you can really do kind of a lot of cool different things. It is also free. We have it installed on these machines, and we'll boot it up in just a second. It's constantly going through updates, so you're going to see new updates release over the course of the semester. If you get your account, and you can get an account here on the website, create a Unity ID, you can download the free version at home and use it on your Mac or PC. It is cross-compatible, and the projects you create are cross-compatible. So don't worry about making a project on a Mac and then coming to the Classroom PCs. All of that will be fine. There are going to be some small differences because we have the pro licenses in this lab, which is awesome. And you will be getting the free licenses at home. But it won't impact the stuff you're doing on your projects at all. So you don't need to make a Unity ID today. I thought you did because we had to last semester, but these machines have now been licensed. This is optional if you want to use your own computer or laptop or home computer, create a Unity ID and download the engine. And like I said, it's always updating. And one of the challenges with Unity is the cross-compatibility of projects. So while you can have a Mac or PC, that interaction is fine. If you have a project that's on one number different, it's going to complain and say, hey, do you want to upgrade or do you want to downgrade? And then it's going to get confused and potentially break things, and it's not going to be happy. So what I recommend doing is sticking to a version and sticking to the same version that we have in on these machines. And I'm going to show you how to find that for your own computers. But let's open up Unity Hub. Unity Hub is a tool that lets you manage your engine versions, manage your projects, access tutorials, and things like that. And this can be done by going to just Windows and opening up Unity Hub. Now, if you open Unity Hub and let's see, let me remove this project from earlier. If you open Unity Hub and you click on installs and you don't see this, if it says please install a version of your engine, close Unity Hub and then just type in Unity and open up Unity first, and that will tell Unity Hub, hey, there's an install on this computer. So it will reopen Unity Hub, but it'll just go through it the right way. So if you're not seeing anything there, just close it down, and instead of Unity Hub, open up Unity. That will fix it. Okay, so like I said, versions are a challenge to work with. These machines have, I hope you have the same version, 2019.2.16 F1. So Unity has moved to a yearly release cycle where they have maybe 2, 3, or 4 big releases throughout the year, and then sub versions of that, which is this third number, the 0.16. The F is small iterations, little fixes, and the F won't cause compatibility issues between projects. So if you were on 16F4, I'm pretty sure, I believe, you can still open projects from F1. However, if you are on 17, Unity will definitely let you know that there's a compatibility issue. And in general, upgrading isn't a problem, right? You can always upgrade your project. It's coming back down and downgrading that causes the issue. So it just so happens that since these machines were installed like 2 weeks ago, Unity have released a new subversion. So on your home machines, how do you go and get the correct version? Well, you can go to add, right, and add a new version of the engine, but this only shows you the main sort of the latest releases. So we have 2019, we have 2018, and 2017. We do not have any of these subversions from 2019. 2020, are we ready for 2020? We should do it. No, don't do it. The other thing is you can't install new versions on these machines without my password, so I don't know. Sometimes teams upgrade and I'm like, why? Now I have to go through and type my password into all these computers. But it's okay. So yeah, the 2020 version, it's in alpha. It's probably buggy and weird. Don't do that. It might have some cool stuff, but probably not. So how do you get this specific version? Well, go back to Unity, and you can get to it by clicking on, yeah, okay. Click on Getting Started, and then find in the resources, older versions of Unity. You might be able to just Google search Unity older versions or something like that. It's going to give you this download archive, which gives you access to all the subversions. So we're using 2016, which was from December 18th. I guess they released a new version. Guarantee there's going to be like 3 more over the course of the semester. Probably it'll move up to, well, no, probably 0.3 is, I may do 0.3, or they may just go straight to 2020. I don't know. But anyhow, if you need 2016 on your home machines, this is how you get it. You can open it straight in Unity Hub, and it will say, hey, what do you want to install? A second. More than a second. Okay. Let's try that again. Well, usually it works. Oh, there we go. Oh, it's already installed. Oh, right. So you have to do, oh, let me click a different one just so you can see this install window. Okay, so when you install a new version, it's going to ask you what build support you want. You don't need any of these unless you want to build out the game, which you probably want to do. So at the very least, if you're on a Windows or even if you're on a Mac, do Windows build support. That way you can put an executable out and submit assignments and all that. So this one's fine. Documentation, if you need any other language packs, whatever, that's fine. I'm not going to install this because we don't need it, of course, but just wanted to show you that's kind of how you do that. Okay, so let's go into the projects tab and let's start a new project. So this is where your projects will live once you've created them on this computer, right? This doesn't mean that your projects are going to magically show up here if you just sort of download your project from Google Drive or something like that. So if your project is not showing up here, you can always go add your project to the list here, and you just need to find the project folder. And and add it in, and then you can launch it. We're going to click New, and I'm going to show you, take you through this screen, which shows you the different sort of templates that you can build from. So the most common are 2D and 3D. 3D with extras, I actually don't know what that is. I guess it just has some example content in it. That could be super useful, but I haven't ever played with that. These two down here, high definition render pipeline and lightweight render pipeline, are both new things that are just barely out of being in sort of preview / beta. And they are very cool. They do the high def render pipeline does some amazing stuff with increased lighting quality, volumetric lighting, better processing, better shadows, stuff like that, to make your games more cinematic and more realistic. We probably don't need that. Yeah.
So it's like
yes and no. Like everything's going to function on the surface the same way. It's just under the hood it's very different, and that means shaders and materials are very different. And so I've had teams use the HDRP for their project, and they've done some really cool stuff with like volumetric lights, and it's looked super gorgeous. But they had a terrible time updating all of their materials and models and stuff.
so like it has all the same features.
Pretty much. No, I don't know, and I really want to know. It's just I haven't tinkered with it too much. From what I've tinkered with, I would say that the big improvement, like I don't think it's doing anything as far as real-time ray tracing. I don't know that Unity have implemented that. If they do, it'll probably be into HDRP, but it does better stuff with just the way that lights and models are shadowed and shaded. There's nothing that's fundamentally different about like the shading model is still PBR like under the hood. But I know that there's a lot more care and attention paid to like the fidelity of how something looks. So shadows seem to be a lot better. Lighting seems to be more accurate. But yeah, I haven't played with it too much. I really want to. It's there's a little bit of an overhead, but I wouldn't say it's any more complicated once you adapt to it. It's just adapting is the hard part. Yeah, and then lightweight render pipeline on the other end is for mobile devices and stuff like that. So it's where HDRP has just a ton of features and requires a ton of GPU and processing. Lightweight is the opposite end of that spectrum. And there is a lightweight VR pipeline template that they're working on as well, which I kind of like the sound of, but again, haven't played with that too much. There's, just so you guys know, like Unity, they go through so many changes and so many improvements on monthly, yearly basis. Like there's a whole new set of features coming in called DOTS, which is Data-Oriented Tech Stack. And that has the ability to do crazy, crazy things. I might show you some stuff later in the semester. But Unity is always changing, always improving. It could be the case that some of these things that you learn in this class are just, gone in a couple of years or 5 years or something like that. But that's part of game development. Every tool evolves and changes with the technology, and so that's just kind of part of the process. Okay, so let's. I wanted to tell you the difference between 2D and 3D as well. So 2D, as it implies, is for games that have two-dimensional assets, so sprites, and Unity doesn't handle vectors unless you add some plugins. So it's a sprite-based workflow, which is basically PNG images, JPEGs, if you want to go crazy. PNGs are the sort of standard. But a 2D game, 2D gameplay, so it's all squashed. There's no Z-axis. It's all flattened to a 2D world. Or 3D, which obviously gives you all 3 dimensions. Under the hood, Unity is always a 3D engine. They have optimized things and given you features that make 2D games more performant and easier to work with. And these features have been coming online in the last couple of years in a pretty cool way. So you can use tile maps to draw environments, or even create sort of like 2D landscape curves and things like that, which is super cool, and I'm super excited about. But under the hood, it's always going to be a 3D engine. And let's say you wanted to make a 2.5D game, so 2D gameplay and 2D physics and interactions, but 3D assets. You can absolutely do that. You could start off with a 2D template and add 3D models. That would be fine. You could start off with a 3D template and then use 2D collisions and 2D rigid bodies as the component that does physics. So you can go back and forth between these things or mix them together, and that is absolutely okay. What this selection does, is it just changes some of the default behavior and properties of the engine. So sprites will come in as sprites instead of textures. The cameras will be set up in an orthographic perspective, meaning it's not rendering depth or not rendering perspective, versus a normal sort of perspective-based camera. So little changes here and there, but you can always go back and forth. One thing to note is that for a 2D game, Unity treats your 2D axes as left and right and up and down. So if you were making like a dungeon crawler where you wanted the 2D perspective to be flat on the ground, and have physics and things like that, I mean, you could maybe make it work, but it would be a little bit tricky. So for the game we're doing, it's going to be a top-down sort of twin stick-y style game with some avoid 'em up sort of navigation exploration type gameplay. So I'm going to choose 3D. I recommend you do the same. Yes, question?
So what if a game developer wants to provide elements of I think what
Yeah, that's where it gets into the sort of more custom setup that you're going to need to probably figure out on like the programming perspective and the implementation side. I would say I've had some teams actually do really cool things with 3D models that are built out of like just 2D billboards. Like Enter the Gungeon does this. It's all 3D billboards, but it's an orthographic camera, so everything renders like it's a 2D game, but it's actually 3D. You can do some really fun stuff with like lighting and things like that. When you get into the engine, you can adapt it to do basically whatever you want.
So I guess you were saying that for the 2D, more design for
Yes, it is. It absolutely is. That doesn't mean you can't disable gravity and do something that feels like it's on a top-down thing, but like one of the most frustrating things is like the whole navigation, the nav mesh system is built on the ground plane, and 2D is built on this plane, so like you can't get them to work together. I ran into that. I was like, no, but that's okay. That's what A star is for. A star, the just pathfinding. Okay, so give your project a name. I recommend using your real name, just because this might be the project you end up submitting. So I'm just going to use first initial, last name, and then you can send it to any location you want. I'm going to stick it on the desktop because I don't want it to go some networked folder or something weird like that. And yeah, so if you got 3D selected, you've got your name and location, go ahead and click create. Okay, so before we dive into the engine, I want to go over what gets created when you make a Unity project and why that's useful to sort of know about and think about as you start to work on your projects. See if OBS is still going. Yeah, it's still recording. Great. Good to you, OBS. Whoa, it's trippy. Don't do drugs. Okay, so I'm going to just minimize this and we'll get back to it in a second. So here's the folder that got created, that obviously named what you named it when you made it. It's about 27 megabytes big, so there's just some default stuff that gets created and put together. And inside of it is a whole bunch of subfolders, and then like in library, there's a whole bunch of random files, and it's a big mess. Game development projects are not, they're never just a single file, right? They're a collection of assets, and those assets may be models, they may be scripts that you've made, they may be material definitions, and more. They may be sort of engine-specific setup files. If you look in project settings, you can see, these are all assets that tell the Unity editor how to set this project up, right? So when you go to save your project and put it on Google Drive or Dropbox or whatever, and then work on it at home, it's never good enough to just like grab one of these folders. Theoretically, you could just grab the assets and then convince Unity that this was a project and be like, hey, open this back up and try and make it work. And it probably would, but it's better to understand kind of what functions these have and what you need to save and what you can safely delete if you need to delete something. So assets, very important. That's where all of your content is going to end up, and that's kind of the core of your game. Library is data, and this is where all the data is located. You can see it's 27 megs. This is where the data gets created by Unity to handle the sort of operation of using the editor. And just to demonstrate what you can do, you can actually delete your library. Oh yes. And you might think it will break everything, but when you go back to Unity Hub and you launch your project, it will go through and regenerate all that stuff. So when it was first setting it up, that's what it was doing, is generating the content in library. So library can be deleted. It often takes up the same or more space than your assets. So if you have 500 megs in your assets folder, your library will be that or more. So it just takes up extra space. It does take time if you don't have it to generate it. So it's not something you want to do. If you're working on a computer, you don't want to just randomly delete your library for no reason. But if you're trying to save space, you're trying to upload something, you can trash that and still get your project. When you work on version control, so when we set up GitHub or SVN, whatever it is that you're working with your team, if you have your library as part of the committed files, it will break everything and your life will be miserable. I have several teams every semester wonder why every single commit they do has conflicts. And it's like, well, did you use a git ignore? Did you ignore your library files? And they're like, no. I was like, well, when I told you to do that, why didn't you listen? And the only solution is really just to burn down your repo and start a new one. Because once those files have been committed, it's very hard to like get GitHub to actually ignore them. And the problem is, anytime you use the engine, it's always tweaking those library files. It's saying, hey, you changed this. Hey, you updated that. Hey, under the hood, I updated this. And so anytime you go to commit, it'll say, hey, you have changes, right? Those changes will get pushed to the server. And then when anyone else plays with their version of the editor, the project, they'll have commits on those files that don't need to have commits or conflicts, sorry. So long story short, and I will remind you of this when we get closer. Your library is an important part of working on your game, but dangerous if you misuse it. Logs, temp, those are things that you can delete as well if you need to. I think packages is required. Project settings is always good to have, but library is the sort of main offender. Okay, so that is your project. We'll look more in the assets in a little bit. But for now, let's dive back into the engine and start going over what it does. Let me go back to my default layout, so it's the same as yours. Okay, rad. Hey! Oh, you good. I'm just going over basic stuff today, so.
I'll come back when we're done talking to you.
Okay.
Because we all had to present for 1 minute. There's 69
Hours.
Nice.
Nice. Well played. Okay. So this is how the default layout looks. I'm going to go over each of the windows, so you know the functionality there, and we'll dive into stuff in more depth. But what do I want to tackle first? Okay. Well, first and foremost, the scene. So when you work with Unity, oftentimes you are working within a scene. So Unity calls them scenes, Unreal calls them maps, GameMaker calls them rooms, I think. A scene is a collection of objects, often a lot of 3D objects, some functionality. So you may have scripts attached to those objects to do different things, and a lot of what you do is sort of arrange things and apply functionality or edit settings or whatever else. But it all has to do within a specific scene. Now, a scene is often like some sort of specific kind of like collection of things. So like a main menu is usually created as a scene, a separate scene. A level might be its own scene. You can transition between scenes, and I'll show you how to do that down the road. But for now, just know that you've got a scene created by default. It's called Untitled right now because we haven't saved it, or maybe Sample Scene. That's weird. Okay, I think that should be what we're saying. So within Sample Scene, Unity has created some sort of placeholder objects for you to use. One of them is a main camera. You can click on that over here in the hierarchy. So on the left-hand side, you have the hierarchy with your scene, and if you drop this little arrow down, you can see all of the objects, or as Unity calls them, game objects, that are included in that scene. You can rename and reorder these. You can parent them together. We'll get into that down the road a little bit. But the objects that are created, can be selected here. And then as you can see, it is in your scene view, selecting them and showing you, your transform tools, gizmos. On the right-hand side in the inspector, it is also changing stuff. So it's showing you the settings or properties of these objects that you can modify. So you can take your main camera and, you can change the field of view of that camera. You can change it from perspective to orthographic. So that's effectively turning it into a 2D rendered thing if you go to orthographic. You can see, there's other stuff you can play with here. There's also this transform, and the transform controls its position in space through position, rotation, and scale. Scale doesn't do anything for a camera. Obviously, it's not something you're going to need to mess with for a camera, but certainly position, you can grab these fields and move them up and down. Or you can use the gizmos that are in the scene and move them up and down, left and right. Now, navigating in the scene is done in a couple of kind of easy ways. The way I move around by default is holding down the right mouse and dragging, which is going to pivot your view perspective like you're playing a FPS game. And it also shows you that little sort of 4-key thing to indicate that you can use WASD or just WASD to translate around the space as long as you're holding right-click down. You can fly around, you can zoom, get closer on stuff and move away. And if you wanted to go up and down, you can use Q and E to do that. You can also kind of zoom in or dolly in, I guess would be the correct term, using the scroll wheel. So not holding right click, just scrolling up and down is going to let you do that. Smooth dolly. Yeah, that kind of is. So the other way to zoom or dolly is hold down Alt and then right click and drag, and that is gonna do that. Alt is also nice because Alt and left click is gonna orbit. So that's very similar to Maya, right? You have orbiting, And then you also have F as a hotkey. When you've selected an object, F will frame it. You can also double click on an object to frame. So those are the two ways that I usually get around. Is like if something's way off screen, I just select it in the inspector, press F, and then I'm there. If I'm close to something or moving around a more kind of detailed environment, I usually use WASD.
What options are there for
I think very limited, which is kind of unfortunate. Yeah, there might be more. I know they've adjusted some. So like, if you hold down Alt, what is it? Yeah. So if you hold down right click and scroll wheel, you now get this like times modifier, and I think that is your zoom speed. Let's see if that is, but no, something else. Oh, that's your movement speed. That's right. So you can move faster or slower if you right click and do the mouse wheel. It's kind of nice. I mean, Unreal has, my experience, Unreal has better movement controls once you adapt to them, but I don't know, they're not bad.
somehow like way to use the keys or the mouse buttons?
I don't know, maybe. Not that I'm aware of. You could figure that out, check it out, yeah. Okay, so that's how you navigate around in your scene view. There was some, oh yeah, gizmos. So also adopted from Maya, the W, E, and R will keys on the keyboard will select your three transform, translation, rotation, and scale gizmos. Those are nice. Up in the top here, you have global and local, like translation space, I guess. So if you're on, if you're on local space and you're doing rotation, that's usually way better than going to global, which will reset every time you release, right? So pay attention to the global versus local rotation. And also when you get more into depth with sort of objects that have nested properties and colliders and stuff like that, your pivot point being either in the center of the mass or mass of the object or the actual origin of its parent. That's way confusing, I'm sorry, but that pivot point is also kind of useful to know about. So just know that those settings exist, and if you need them, you can do that. Now there are some more gizmos up here. There's this rect tool, which we'll get to a bit later, and there's also this sort of like overpowered translation gizmo, which has scale and rotation and translation all mixed together, because why not? So that is kind of fun. Okay, so that's how you interact with the scene view. Now, when we select our camera in the scene, you can see that we have this little camera preview. So this is showing us when the user presses play and starts the game, this is going to be what they see. And if we hit play up here, it's actually going to change windows so that our game window, which was just hidden, pops to the surface. I don't usually have my windows set up like this. I don't like that it does that, and I like to keep an eye on what the camera is seeing. So I usually grab my game window and just pull it and dock it right next to the other one. And I wanted to do this as well because the way that Unity handles the camera is just a little bit, I don't know, it makes sense, but it's not intuitive, I guess, at first. So let me go back to my, all right, sweet. So it's kind of hard to see what's going on, so I'm actually going to drop in just a simple shape. So if you want to add simple things to this scene, you can go to the Create menu here, or you can right-click in the blank space down here and go to, I'm going to go to 3D Object, and I'm going to pop in a plane. And so that's added it to the scene. It's added it to the list here. We can double click on it to sort of frame it in the view. But it has put it in kind of a weird place. It's put it in the center of where we were looking. So we might want to return it or set it to the origin point of the world. And we can go to our position in the transform and just put in zeros here and zero it out. So Now, I like having these two windows up for situations like this where it's like I want to be able to see kind of, through the camera lens essentially as I'm moving stuff around. So the first thing I might want to do is just kind of adjust my camera position and rotation. The game we're going to end up making is more of a top-down view perspective. So at least I want something that's kind of, looking down on the gameplay, maybe at like a 55-degree angle, and maybe 10 high and -10, -8. Okay, so now our camera is kind of framed up in the center, like the origin of the world, and kind of oriented. We can make adjustments, but it's kind of oriented to the view perspective that we want. The thing I wanted to show you about cameras, which is the sort of not intuitive thing, is that when you drop a camera in and you have your game view kind of right next to it like this, as you can see, when I'm adjusting the size of this window, the size of the camera view, let me zoom out a bit, the aspect ratio changes to match what I have over here, which, again, makes sense, but for most purposes is kind of the opposite of what you want, right? You want to be able to see exactly what the player is going to see when they hit play. So the reason it's doing it is because it's set to free aspect by default. So you can change in your game window this free aspect to, say, 16:9, which is, most TVs and most computer monitors, so that's a good one to go for. And now it's going to lock that aspect ratio in the game window, which in effect is going to do that to the camera. So now when you change the size of the window, it's not going to change the aspect ratio. And it's going to show you a different view, right? Because if you do free aspect, it looks like this is big, right? It's taking up almost the full screen. But now we go to 16:9 and it feels a lot smaller. So it's much better to do this early because then you get a sense of like, okay, this is how the player is going to see it. And you can adjust things from there. So like the field of view maybe, could change, or the distance from the object could change. Okay. So next on the list, we have talked about the camera, and we've talked about objects a little bit. I want to talk more about game objects, and most importantly, what is going on in the inspector over there to make these game objects do what they're doing, essentially. So the thing to understand is that at the root, everything in your scene, every one of these items in your scene is what Unity calls a game object. And a game object has certain standard default properties which it needs to have in order to just exist as a game object. And if you look at these 3 different game objects, there are some things that are different. This has a light, this has a camera component, and this plane has a few different components, a mesh filter, mesh renderer, and a mesh collider. But they all share this top part, which is a transform component, and things like a name and an active state. So you can disable and enable a game object by checking this checkbox. So I disabled the light, it went dark, ish. The skybox is actually casting some light behind the scenes, but you can see what it's like turned on and off. That checkbox can be accessed just as easily through code as in the interface. So any of these properties as well can be accessed through code. You can say, hey, game object dot position or dot position or dot transform dot position equals a new set of numbers, right? And if you have that in your script in an update loop, it will set that object to that position. Or rotation, or you can increment the rotation or the position. So that's how to do very simple sort of rudimentary gameplay. It doesn't handle things like collisions if you're just setting positions and rotations, right? So often we rely on the physics system to handle a lot of the sort of movement of gameplay and interaction because we need collisions to fire, we need physics to be obeyed, gravity or mass or something like that. But at the end of the day, if you wanted to teleport an object to a certain location, GameObject.transform.position, set it somewhere. So that's great for like resetting a character at the spawn location or something like that. So all game objects have this standard kind of signature with transform and tag and things like that. What you add to a game object determines how it operates and behaves in the world. So as an example, I can right-click in my sample scene and go create empty, and I'm going to get a blank game object, which I can reset to 0, center of the world, frame it up. And it's going to have those elements we talked about, but it's not going to do anything above and beyond that. But we can absolutely change that. We can add components to build this object to have some sort of functionality that we want to see in the game. So for example, let's say I want to, instead of this directional light, I want to change the lighting in my game. I want it to be more of a dark kind of feel and have point lights, which feel more kind of scary or immersive or something like that. I can take this game object, let me move it up a little bit, and I can go to my add component list, and these are all the components I can add. So tons of stuff. I can make this game object do tons of different things. I'm going to search for light and give it a simple point light or simple light component. And now it behaves almost exactly the same as my directional light. It's not behaving the same because these settings are different, but functionally it is a duplicate of that object. So a point light behaves differently than a directional light, right? A point light is a point in space that emits to a certain range, and it has a smooth graduated fall off across that. A directional light is a point in space, or really it's just an angle, a direction, and the light is cast uniformly across the entire level. So a directional light is way more efficient, just so you know, than a point light. A point light is essentially, this is a little over complex, but it's essentially 6 spotlights with 90 degrees field of view. So it's 6 times less efficient than a single spotlight. But we can change the type of light here to spot if we wanted to. A spotlight that casts kind of a cone of light. Move it up a little bit so you can see that's the spotlight. Range you can play with is going to change the intensity as it hits that plane. The spot angle is going to do that too. So like a common thing in a lot of games is just to stick a spotlight above the player character, right? Was there a knock at the door? Do you want to pop it open and see it? And that way you can see the environment, you see the player and the environment around the player in some sort of detail. You can change the intensity here, which is going to obviously change the brightness, change the color. Looks kind of cool. So any game object can be changed and modified to behave differently depending on what you want to do with it. And obviously, these are simple, primitive placeholder sort of template objects. As you go further and you create, enemies that have pathfinding, that have weapons and attacks, and maybe they, drop things when they die, those are all features that are going to be added through components that Unity have built and also scripts that you have written. So a script is nothing more than a component that you're going to attach to an object. That's how scripts get used most of the time in Unity. It's not 100% the case. There are plenty of times where you're, just having some data or communication between objects, the architecture of the game. But most of the time, the functionality of gameplay is determined by scripts that you've written that you apply to game objects. And we're going to go through that a little bit later. For now, just know that, if you want to figure out how an object is kind of functioning, like this plane, you can kind of go through and toggle stuff on and off. So like the mesh renderer, well, what's that doing? It's drawing it to the screen, right? If I toggle this component off, it's going to disappear and leave this weird green thing. The green thing is the mesh collider. So if we turn that off, that goes away. And notice how that isn't rendering in the game, it's just rendering in the scene. So there are plenty of things like this camera icon, like the light icon, and like when you have it selected, the collision information here, that are only going to show up in your scene view because it's information that you want to see. The player doesn't need to see that. So we have a mesh collider here, and we have a mesh renderer. Let's play with one more component and start playing with some physics. So physics is not applied to these primitive objects by default. Physics is one of those things, along with collision, where you want to be a little bit careful. You don't want to have a ton of physics-enabled objects in your game, just because the computation time on the processor to handle the physics on those objects and potentially collision between objects and things like that. You want to minimize the amount of like complex colliders and physics-enabled objects as just part of sort of optimization. For your stuff, for your games, they're going to be so simple that you're never going to run into those issues unless you start having thousands and thousands of objects. And Unity is really pretty efficient, so you never really need to worry about this, not until you get into high poly counts and high complex collisions and stuff like that. I'm going to add a cube. I'm going to go 3D object, cube, and I'm going to drag this dude up, and I'm just going to rotate it a little bit so it falls. When it does fall, it falls, not straight down. It has a little bit of angle to it. It's not casting a shadow because remember how we set up our light? We didn't enable shadows, so that's good to know. Right? We can change this to hard shadows or soft shadows. Hard shadows are a little bit more efficient. Soft shadows are more accurate. Let's go soft shadows. Okay, so now it's kind of cool. This light source is like casting directly down on this object. And you can see as I move the light source, the shadows change, the lighting on the objects change, of course. That's pretty nifty. So when we hit play right now, nothing's going to happen because, again, we haven't told Unity to calculate physics and physical interactions. But we can do that on the cube by adding a very simple component called a rigid body. So you go add component, rigid body. Again, 2D and 3D have been separated here. So if you were working on a 2D game, it's more efficient to use the 2D colliders and make sure you're sticking to all 2D or all 3D. Those two systems don't interact. We're going to go with the standard one. And now let's press play. I think it's going to fall straight through because of a weird quirk of Unity, but let's press play anyway. Oh, no, it didn't. Awesome. So what you can see happen is just the cube falls down, right? It has gravity applied to it. It has mass, and it retains its angular or its linear momentum and hits the collision and changes to an angular momentum. Unity's physics system is not bad, but it's not amazing. There are definitely some shortcuts to make it as performance focused as it is, and rotational things often cause problems. But this does a pretty good job, right? And you can populate hundreds of these things, and they'll all interact in a fun way. So adding a rigid body adds that physics. We only added the rigid body to the cube. The plane does not have a rigid body, right? And this is kind of an interesting distinction because we've enabled physics on the cube, yet the plane is still interacting as if it were a real thing. Unity is treating the plane as like an immovable object, right? It can't take any force information or it receives collision information from the cube, but it can't move its position based on physics. We could absolutely add a rigid body. And if we hit play now, guess what? They're both going to fall because it has gravity. You can turn gravity off for a rigid body object, so that's cool. Okay, and now it falls through. So that's where the weird quirk is. If you want to do this, you don't have to do this if you don't want to. It's not part of the thing, but toggle the convex collision. Mesh colliders, just put this in the back of your brain. you shouldn't use them unless you really, really need them. And only then should you use a mesh collider that has a low topology, because they're very finicky and take a lot of performance. Box colliders, sphere colliders, capsule colliders, those are the things that most games are built on the back of. But that's kind of cool. So it starts off with no gravity, but then when the cube hits it, it falls, right? So it's now receiving that physics interaction. If you want to ever delete a component, remove it, you can right-click on the name. Let's go remove component. So there's going to be a lot of things like this. I'm going to uncheck convex because we don't want that. There's going to be a lot of things like this. You know, you might have your environment built out of assets that have colliders attached to them, but no rigid body, right? So you bump into them, but you can't ever move them around. But you might have certain things like, you know, if you're building a puzzle game, you might have a block that a character can push along, right? That would have a rigid body on it because you'd want that physics interaction to take place. Okie dokie, so we have created some basic stuff. We've covered how components work. Let's talk quickly about the project window down here before we dive into scripting. So the project window contains your assets as well as these packages. Don't worry about packages for now. That's stuff that you can use and implement as you go, but you don't need to know about it just yet. But the assets you absolutely do, and you need to kind of, you know, be pretty organized with your assets and careful about the way that you you work with them. Unity is way better, or way easier to work with than an engine like Unreal. For an engine like Unreal, you have to go through a very specific import process. And then anytime you might want to like rename or move or duplicate assets, it seems to throw a fit, at least in my experience. It's like leaves these ghosts of objects around in your scene or in your project. Unity is way easier to work with. You can literally just drag and drop content straight into this window if you want. And as we'll see next week when I do some more art demos, you can update live objects. So let's say you have a texture that's open in Photoshop and you're mid-gameplay, you can update that Photoshop texture, hit save, and then Unity will refresh instantly and you'll see that change. So that makes iteration just really fast and fun. Same with models and things like that, as long as they don't have animation. So that's great. It does mean that some of the advantages of having a more strict asset library are just not possible. And this has to do with games that are much larger in scope, multiple, dozens of people working on them, big projects. And so for big projects, I actually prefer Unreal because I've gotten into situations working on larger teams with Unity where this asset management has just become a nightmare. But things are sort of improving a little bit at a time. So your assets, like we looked at before, are the same. All right, this is a mirror image. So what it's showing you in here, the scenes folder, is the same as the assets in your Windows directory. So you can go back and forth on this. You can create a new folder in Windows. Let's call this folder materials and go back to Unity. Boom, I have a new materials folder. Great. You can go into the materials folder and I'm going to create a new material. Right click, go to create and choose material. I'm going to call this one floor. And then if we go back to Windows, I have a new floor material with a .mat file extension, which Windows thinks is Microsoft Access Table shortcut, which it totally isn't, but that's okay. So a couple things to note here. You can modify, change, and reorganize things inside of Unity or inside of Windows, and that is generally fine to do. I would recommend doing it inside of Unity because as you start to work, there are files that are hidden that are called meta files, which have specifics about how assets have been imported and things like that. So usually I reorganize, rename, and alter files inside of Unity because it's a bit better practice. But you can do things differently if you want to. When we went to the create menu here, we had a whole list of things that were different than the create menu inside of the scene, right? And this is kind of an important point to wrap your head around with Unity. The content that you create or you import inside of your project, imagine that it's like the kind of box of toys that you're going to make your game out of. And when you start building out your level, you're taking individual pieces, individual toys from that box and adding them to the scene. And these things that you add in might be models, they might be materials, they might be sound files, whatever it is, but there's a distinct difference between the type of content that exists in your project and the type of content in your scene. Your project doesn't have game objects, right? Unless you create a prefab, which I will show you how to do in a bit. Your project has things like scripts or things like 3D models. And then when you want to add them to the scene, you can go through a process like dragging and dropping them into the scene. For this material, we can drag and drop it onto an object in the scene. I'm going to actually change the color so we can see that it's working. So I'm going to change this to like a kind of dark green. Also to note, your inspector is going to show you properties of whatever you have selected. So if you got something selected in your scene, inspector is going to show that. If you've got something selected in your project, you can edit those settings on that object. And now I can drag and drop this onto something in my scene, right? I'll put it on there. So this division between the type of stuff in your scene and the type of things in your assets and in your project becomes a little bit blurred as you start building out your game. It's often the case where you don't want to have to go through the process of duplicating 200 different enemies and putting them in your scene, right? You might just want an object that will spawn enemies into your scene and create them during gameplay. You can do that, and you can create a link between a script that is functioning and operating in your scene and an asset that's in your project. And I'm going to show you, not today, once we get into the more programming stuff, how that connection kind of works and how you can connect things between your scene and your project. Typically, that connection only goes one way. Your scene can access stuff from your project, but your project would never access things in your scene, right? It just, yeah. The project is like, like I said, all the toys, and then when you build a scene, you kind of pull those into your level and populate them and mess with them. Okay, so we have created a material. We're going to look more at materials and textures and things like that this next week. So I'm not going to go into details on what you can do with this material. I just wanted to show you kind of how you do that, how you can change the color of things, because it's pretty simple. I do want to show you how to create scripts and how to work with them. So a script, like I've said before, is most times nothing more than just a component that you're going to add to a game object. They might not look as fancy as these components that Unity has built, but under the hood, the same thing is happening. These have fancy icons and inspectors with lots of fold-out menus and stuff like that. You can do the exact same thing with your scripts. In fact, I have and many people have built tools inside of Unity to do things to help them build the game, right? You can have a level building tool that lets you populate a level very quickly, or set up AI pathing or something like that. And you can customize your inspector and create, a whole tool inside of your inspector if you want. So Unity have done that, and they've exposed certain properties that are commonly needed to be kind of worked with. So like if we click on the floor, when we dragged and dropped that material on, that added it to this floor material spot, right? And we can click on this to see what it's referencing. So you can change the material of something. You can change the blend mode of the light probes. You can change physics materials and things like that. And this is these are the settings that Unity have decided, would be most commonly used. That doesn't mean this is all that this can do. And if you access this component via a script, you might see dozens or many more variables and functions that you can play with. And we're gonna dive into that. But just know that while this looks kind of fancy, it's just a script like anything else, and it's going to be the same as the script you make. So let's start off making some scripts. Let's right-click and add a new folder in your project, your assets, and I'm going to call it scripts. And inside of the scripts, I'm going to right-click again and go to Create C# script. It's going to ask for a name. Naming is important with scripts because if you name it something and then change the name later, Unity might get confused. It's also important to avoid certain names because Unity have already taken certain names. And this is like, you're not supposed to know what these are. I think Game Manager is taken. Player something or other is taken. I think player is taken. Yes, question.
Wait, so when you're like, manipulating like files and stuff and renaming them,
So you're renaming files and manipulating stuff inside Unity?
Yeah.
What do you mean?
I mean, like, avoid naming it certain things.
Oh, well, it'll complain.
So it will give you like.
Yeah, it'll give you a console error like, what is it? It's something like, yeah, basically when it can't tell which it's supposed to. Yeah, something like that.
So like when you rename it, it won't give you like some option to change all the references.
You'd have to refactor inside of like Visual Studio or something like that, and then that would be dangerous because it might refactor something you didn't want. I'm just going to call this player input. I think we used this one earlier, so I think it's fine. I usually don't run into that. That's like a pretty rare case. Usually you kind of name your own stuff. And you can also use namespaces for programmers in the room. A namespace, will be sort of like pre-appended to any script. So it will be my awesome game dot player input, and that will avoid any conflicts across naming. Okay, so player input. So we created this script, and if you single click on it, you can see in the inspector kind of a truncated preview. Most of the time it doesn't show you the full script because scripts get long, right? But it shows you this, what's been created. So there's some template for you to sort of work from, which is nice. What was the other thing I was going to say about scripts? Can't remember. Let's double click it. Open it up. Oh, well, yeah, we'll get into that in a second. So in the previous class, we discovered an issue with Visual Studio and autocomplete. It was not using Unity's autocomplete stuff. So everyone who has this up, go just click in your start method and just type in game object. And if you see these two things, or type in game, and see if it gives you these two options, game object. If it's not doing that for you, which I'm sure like half of the class, because we only fixed half of the computers, follow these steps. Close down Visual Studio. In Unity, go to Edit and go to Preferences. Got that. And expand the window, the Preferences window, because it's like tiny to start out. And then click in External Tools. And change your external script editor to Visual Studio. Okay, so once you've done that, you should be able to reopen your scripts and launch Visual Studio again, and hopefully those autocompletes should be updated. I can't imagine trying to do anything without them, so it's kind of important. Okay, so scripting in Unity. Well, like I said, a lot of the functionality of your script is going to need to be associated or applied to specific game objects. And Unity have sort of interwoven what happens in the scene and what happens in your script with this mono behavior inheritance. Mono behavior does some really cool things for you. It gives you access to certain functions which will get called as long as they exist in your script. And two of these have been given to you by default. So start and update are two of these default like core functions that you're going to use a lot of. And that's all working with this mono behavior using a process called reflection, I believe. You also have access to some other things, like you can access the game object that this script is attached to and the transform. Those, like I said, have to be a part of the game object, so it's easy to access those. You can access other components with a function called getComponent that we'll look at in a second. But there are certain ways to get information that's happening, events that are happening in your scene to call functions in your scripts, right? A lot of the sort of basics of gameplay have to do with environments, sort of interactions or collisions or whatever it is. So collision is often a good way to get information and events from gameplay into your scripts. And one of the things we'll look at in the coming weeks and use a lot of is a function called onCollisionEnter. This one has a little bit of a different signature. It takes the parameter collision variable in. You can see that back there. Takes the collision variable in so you can access things like, hey, what object collided with me and where was the collision point and stuff like that. So we're not going to use this today, but I just want you to think in terms of, that this mono behavior gives you a ton of useful information. So start is called before the first frame update. So as soon as the user presses play or as soon as the scene is loaded, start will fire. And then update happens once per frame. So our frame rate's typically, locked at 30 or 60 FPS or higher. The update is going to happen, that code in the update is going to happen on every frame. So this will spew out information if you're printing some statement out or something like that. It's obviously, a lot of gameplay has to do with that real-time component, right? So you're moving around in the scene, stuff's flying around. A lot of that operates on an update loop on the real-time aspect. But certain types of games, like maybe puzzle games, strategy games, or more turn-based games, usually function on a more event-based system. And no game is exclusively handled in an update loop. And I don't know that any game would really be exclusively event-based. Usually it's a hybrid between the two, right? You might call an event, broadcast an event or call a function on another game object or something like that when you wanted single things to happen. And then for a more sort of real-time control, update is often used. Now you don't want update on absolutely everything because the more you have an update, the more processing overhead you're gonna take up. So keep your update, as efficient as possible. But there's not really any way to get around it for certain things like player movement or enemy movement or something like that. So these are just a few of the functions that you can access. There are more, and there's a big long list of them. We'll definitely look at more as we go forward. Let's jump back to Unity, and before we do anything else, because I'm totally going to forget, we want to add the scripts to an object in the game, right? As it exists right now, it's in our project, it's been defined and written, but nothing is going to do anything. It's not going to work. These start, update, collisions, none of that's going to fire because it's not in the scene. So in order to make any of this work, in order to make those functions operate, we need to have a game object in the scene, which is our player. And I am going to start off with a 3D object that is a capsule. So a capsule is kind of a good thing to use as kind of a starting point. If you're somewhere in the world, reset its transform to 0, 1, 0. That way it will sit on the ground. A capsule is nice for a few reasons. It's generally sort of like a humanoid-ish shape. So if you're making, a humanoid character, it's kind of a good place to start. The other nice thing is that it has a rounded top and bottom, and that's going to help a ton when traversing over uneven terrain or terrain that has like ramps and things like that. Because if we were using a box collider, those edges would get stuck together, and that would be super frustrating as a player to, impact a corner and get stuck. Like you've all experienced that in games, getting hung up on geometry you can't see. So a capsule collider kind of evens that out in a kind of nice way. And that's good for our player. Let's rename this to player so that I keep things a little organized. And then we need to add the script. So scripts can be added a couple ways. You can drag and drop them on. But like I said, a script is a component. And once you've defined it in your project, you can just go add component and search for it that way. I usually just drag and drop, but you can do whichever you want. So now we have our player input. And just to see that this is working, I'm going to put a print statement in my update loop. So I'm going to type in lowercase print, put in a quick message in quotes. And once you have that, you can bounce back over and hit the play button. Okay, so it's printing, but where is it printing to? Well, Unity have decided to hide the console, the most important thing behind your project. If you click on the console, you can see, hey, we've got lots of prints. Again, this is in the update loop, so this is spitting it out every 30th of a second. I always drag the console and dock it somewhere visible, because anytime you get an error, when your scripts are compiling or during gameplay, it'll pop up a red error in your console. And so if stuff's not working, that's the first place you want to check, right? Clear that out. Okay. So our player input is functioning. Those events are getting called, or those methods are getting called just through mono behavior. If our game object was disabled, those events would not get called. So a script is only going to function as far as those mono behavior events go, or messages or functions, whatever you call them. Those will only function as long as the game object is functioning or is active in the scene. You can start off with it inactive, and during gameplay you can turn it on, and now it's going to function, right? So start will fire, update will fire. If it bumps into anything, on collision will fire. So there's a good amount of gameplay that has to do with sort of turning things on and off, right? If you have a collectible, you might run over it and it might add some data to your player character script and then turn itself off or destroy itself in the scene. And it's kind of good to know that when you turn an object off, it is removing it and all the components from the update or the rendering of the game. So it's not going to be a burden on efficiency. So I typically have, depending on the game, quite a lot of stuff that's turned off by default that only turns itself on when it kind of needs to. Yeah, we'll go into more detail about how to communicate between objects that can be problematic when you have things that are turned off, but that's for another day. Okay, so we have created a player. We have created a script for that player. Now let's make it do some stuff. So I want to create a character that's controlled by physics. It's not the only way to do this. You can have it not use a rigid body and just push it around using using other methods. But I want to show you how to do it with physics. So I'm going to go to add component on my player, and I'm going to search for rigid body again and add that component. And use gravity is fine. I don't mind if it does that. I hit play and it might fall over. It might be fine. Yeah, it's just sitting there. So that's okay. Let's write some code now in our update loop to take a player input from the keyboard, in this case WASD, and apply that to some sort of force on this object, right? And we have kind of the start and the end of the functionality of this. Rigid body, the component actually has a function called add force. So that's the function we want to use on that component. And then we can get input in a couple of different ways. Yeah.
Sorry, quick question.
Sure.
Just recording this or
Recording.
on our screen?
Oh, no, not that I know of. But write down something. I was going to say write down the time, but then the time. Oh yeah, actually the time will be on the display thing. Write down the time, and then you can skip back to this moment on the video.
I guess we just.
Yeah. Oh yeah. Well, yeah, we can look into. I don't think the classroom's set up to do broadcasting to screen share, but I might be wrong about that. We should figure that out. Hi. Do you want to help out if people have questions? Sure. Okay, cool. We're just going through just kind of the last little bit, which is scripting and moving stuff around.
Scary stuff.
The scary stuff, I know. Yeah, if you're scared, don't worry. I'm gonna keep it simple. Alrighty, so a couple different problems. We have to take input. We probably want to modify that, manipulate that input a little bit, and then we want to apply that input or the variables to our character and push the character around. Okay. Okay, so the first thing I want to do is, in my update loop, declare a new variable. So this variable is going to be our movement vector. It's going to be the direction that we are going to push our character in. And the variable type that I want to use is vector3. So I can type in capital V vector3. Now vector3 is a useful variable for game dev because a lot of things happen in 3D space, right? You're either positioning something in 3D space or moving it on a 3D axis vector. And a vector3 is nothing more than just 3 numbers, right? So it's just 3 individual floating point numbers, which mean they can have decimal places. So I'm going to declare it as a vector3 and call it movement vector. And then I'm going to just initialize it as to vector3.0. This is, you don't have to do this, I don't think, for vectors. I think it's by default. I get in the habit of just initializing things whenever I can, because then I don't know, it's a little bit clearer and easier to read, in my experience. So what we want to do is take our movement vector, and our movement vector is going to be the XYZ of where we want this character to be kind of moved towards, right? So on every update, this code is going to fire, and we're going to take some sort of small number and push that character along a certain axis. Now the axes that we want to have the character move along are going to be our red axis here, so X for left and right, and then Z for forward and back, right? Y in Unity is the upward axis, so we don't want to push the character up and down. We want to move them left and right, forward and back. So since we're going to be pushing them, on these axes, the first one I'm going to do is I'm going to set my movement vector .x, which is the x-axis of the movement vector, to something. Now, there's, like I said, a couple different ways of getting input from your keyboard or controller or whatever it is. In Unity, I've built out a system to handle handle different types of input that you can use for this. Now, I will disclaimer, the input system is trash. It is just garbage. Unity is rebuilding it. It doesn't exist in a public forum that I've seen yet. Maybe with 2020 they're gonna push it out.
They don't have
Um,
ETA.
I don't know. I don't think they do. I haven't seen any updates on it in a while. But it's honestly, it's not that bad. But then when you get into like multiple controllers or multiple devices, like, you know, PlayStation versus Wii controllers versus, you know, Switch control, like it just doesn't handle a lot of things very well. Requires a ton of sort of hands-on setup. Cross compatibility isn't great. But we're going to use it because it's simple and easy to use, and I want to show it to you at least. And so the way you access the input system is capital I input. And if you hit period, the first one that should pop up is get access. This is kind of the most common thing you do. And it's a function call, so it takes some sort of data. And what it needs to take, as it says right here, is a string with the axis name. I'm going to show you where to find these, but for now, just type in horizontal, capital H? I think capital H. We'll find out if it's capital H. I think it's capital H. Capital H horizontal. So we're taking the horizontal, whatever that means, input axis, and applying it to our movement vector.x. I'm going to do the exact same thing with movement vector.z. And you can copy paste if you want. Instead of horizontal, I'm going to set it to vertical. And I know this is kind of confusing because it's like horizontal, vertical, we're going forward and back. Just make the switch in your brain that, you know, vertical just means up and down. So up and down arrow or W and S. And we are translating that into a forward and back movement. Okay, last thing I want to do with this is I just want to put a print statement here because we kind of want to debug what's going on with this movement vector and the input because it's a little bit, well, it's just good to know for down the road. So I'm going to do a print statement, and I'm just going to put that whole variable, the movement vector variable, in there and print that whole thing out. Okay, so you can do this if you want, not critical. Okay, so let's hit play, and let's start playing with those. Now, it's not going to move anything, but it is going to do a print statement when we start pressing A and B. So that's left and right with WSD, and then W and S. And you can see on A and B, I've got my x-axis, and it's pretty nifty. It goes between -1 when I'm pressing left and +1 when I'm pressing right. So instead of just simple button input, this is translating it into a left and a right axis, which is kind of cool. I can also do that with the arrow keys. So it's been mapped to different keys, which is, again, pretty nice. And then we have the z-axis doing the same thing. XYZ last number, so that's why it's there. Okay, so I'm gonna pause gameplay and let's scroll back and have a look at what else is happening because it's something else is happening that's useful to know about. Okay, so here on this line I have 0, 0, 0, so this is before I'm pressing any keys, and then I press what looks like the left key, and I have -0.1, -0.1, -0.2. So it's not just going from 0 to -1 or from 0 to 1. It's smoothing that out. So it's turning a binary input into kind of an analog, kind of smooth curve. And it's doing it over what looks like maybe 20 or so frames. So it's adding, yeah, it's like adding an acceleration. And then if you go to the flip side where I release the key, it does the same thing on the other end. So it, instead of going directly back to 0, it falls slowly back to 0 over the course of maybe half a second or something like that. This is good. It's a nice feature to have, but it's also something that can get in the way of gameplay. What we're going to do is tie this input to the rigid body, and the rigid body already has its own kind of accommodations for acceleration and mass and moving something along what would be sort of a physically realistic movement curve. So while we may want this behavior, for some things, we may not want it for others. And in this case, it will definitely compound things together and make the player feel sluggish and slow to control and hard to stop because they'll slide to a stop instead of quickly coming to a stop. And this has a lot to do, especially with a player, in how your game feels. It's not to say that there's like a right or a wrong version of this. A good example is like Super Meat Boy. If Super Meat Boy had this type of acceleration curve and this type of physics interaction, that game would be awful to play. It would be so hard and frustrating, and you'd hate every minute. Because anytime you landed a jump, you'd slide off the platform, right? You'd have to be constantly like feathering your controls to stop your character from moving. Air control would be much harder. Like it would just be a terrible game to play. Limbo, on the other hand, which is a much more sort of realistic animated character, which has, the challenge of that game is kind of like coming to terms with the character control and the feel of really, controlling this human. That might be fine with this type of setup. It just depends on the type of experience and gameplay and the type of gameplay challenges that you're going to introduce. In Limbo, there aren't any really, careful platforming challenges. There's a couple I can think of, and they're all pretty big. There's no sort of like tough landings to make. And so they tuned that game to fit, the style of the character movement. So knowing about it is one thing. Being able to change it is the next. So you can edit any of your input settings by going to the Edit menu, coming to Project Settings. And then again, this is just a floating window, and you might need to expand it if it's small. And then clicking on Input and dropping down the axes. And this is where those magical names, horizontal and vertical, came from. So up at the top, we have horizontal and we have vertical, and the name is declared here. You can change this if you want. It might complain at some point because some of the UI is tied into this input system for controller support of, UI selection. So I wouldn't hack this too much, but you can certainly change things like the left, the button mapping if you want to, and put in different buttons here. And you can absolutely change these two settings, gravity and sensitivity. Sensitivity is how fast it goes from 0 to 1 or 0 to -1. Gravity is how fast it returns. So if you look at something like fire, gravity and sensitivity are set to 1,000. So that's going to instantly click between those, more like a binary input. And so if you want a more responsive feeling character and you're using the input system, maybe you want to crank these up. Oops, not that one. So you can do this or not, or you can play with it depending on what you like. Yeah, question. Yes, just going to get to that. So these horizontals, everything below the mouse is set up for controllers. So this is taking input from a joystick axis, and it's taking the x-axis of the primary thumbstick. You can change the thumbstick to a lot. And this is where the input system starts to kind of fall apart, because if you wanted to set up multiple controllers, you'd have to set up horizontal P1, vertical P1, horizontal P2. Yeah. It's distinction between Xbox is both. So you'll set up the name to be specific to a certain player, and then you'll set the joystick axis to be specific to a certain axis on a certain joystick. Yeah, I have to, every time I mess with this, I have to look up the documentation because it's so confusing. And the input from a joystick, a thumbstick, is going to be different than a binary button, right? Because you have that degree of control between 0 and 1, or 0 and -1, is controlled by the position of the thumbstick, which is why, racing games and things like that, they're better on a controller, because you can precisely, kind of control where the car is going. So the gravity is different and the sensitivity is different. The dead zone is also different because on any controller there's got to be a decently sized dead zone so that any sort of like manufacturing defect in terms of where the controller is aligned doesn't result in random input for your game, right? So if you ever had a situation where it's like, I don't know, this used to happen on the N64 all the time where it was like locked in a certain direction and then just that input was just across the whole game. You're like, why is the controller freaking out? Well, dead zones are a way to get around that. Alrighty, so this is how you kind of hack the input system. If you're doing a multiple controller, like a arena combat game or something like that, I recommend ditching this entirely and forking out some money to buy a plugin. Rewired is amazing. I've had teams use that in the past. It just makes everything simpler. It lets you do wireless controllers. It remaps controllers or reconnects controllers where this sometimes has problems. So anyhow, that's the input side. Now, to wrap up, let's get to the output side, or actually moving the dude around. Any questions? Yeah.
Yeah, so one thing that there is for console inverter.
Yeah. So basic controller support will work if you plug in Xbox. Yeah, you could. Yeah, I mean, you could tie different keys. Like you could do a horizontal. Well, multiple players. You might want to do that, but then you'd want different names in there too. You just add. So at the top of the list, it's just an array, and you can add items to it. Right here, the size. And I've got a bunch more cancels, and I can rename these and reassign these. Or you can. Yeah, right. You can also duplicate things. So you can right-click and duplicate an array element, which is probably better since you might want to just work from something else. Yep. It's all good stuff. And then you can also with the input system, this is great for like firing, projectiles or something like that. You can do input.getKey. Get button. Get key. Yeah, get key, not get button. Brain dead. Get key is going to let you access a specific key on the keyboard. So you do get key, and then you do key code like .space or something like that. And that will return, get key is going to return while that button is pressed down. So it will keep returning. Get key down is going to be the first frame you fire, you press the button down. So you don't have to use the axe keys if you don't.
And so it looks like each of these things, like,
Yeah, exactly. Cool. Okay, so last, there's one more thing we want to do, and I'm going to show you why we want to do this in a second. But for now, actually no, let's skip that. We'll come back to it. Let's get the movement vector applied to the character. So I said before, get component is the way we want to do this. Get component lets you access any component that is attached to the game object that this script is attached to, right? So your game object, it has things like transform, mesh renderer potentially. A game object, get component is going to look at that game object and check all the components, and if there is one of this type, it's going to return that or let you access it, right? So this could be a situation where a null ref pops up if we didn't have a component, a rigid body component on this object. So you might want to do some checks there if you were building this for real. But we know it's going to be on there. And the syntax is a little bit funky for get component, but it's get component, you give it a type with those angle brackets. And then it takes, after the angle brackets, you do a open close parentheses with no data in there. And then now you have access to everything that component can do that's public on that component. So all the public variables, the public methods, those are all accessible, including things that we've looked at in the inspector, which is stuff like use gravity. I think that's in here somewhere. Yep, use gravity is just a Boolean that you can toggle on and off from a different script if you want. We are going to add force up at the top, and add force is a method that takes, surprise, surprise, a vector 3. So we can just take our movement vector and plug it in there. Okay? Pretty simple. And if you go back and you hit play and you try and move around, you will enter drunk mode, where your character just falls over. But you can still roll around, which I really like. Great. So this next step is a little bit of a hack. There are probably other better ways to do it. But one of the features of a rigid body is the ability to constrain that object in certain ways. So if you go to your rigid body in the inspector and you come down to constraints, click that little arrow to open it up. And then we're going to want to freeze rotation on X and Z. And so that's Y rotation is going to be around our the upward angle. So if in the future we wanted the character to like turn to face a different direction, you know, we might want that. So I'm going to leave Y unchecked. And then you could also freeze Y position, and then it wouldn't like ever drop down below the floor. That might be useful, but I'm going to leave that unchecked too. Yeah. Oh, do you have a technical question? Yeah, TA question. So try that again, and nothing. So if you try that again with those constraints, it's still working, but nothing happens. And we're going to just need to add one more feature to get that to work. Yeah.
Sorry, this is just like a C# thing, but the brackets.
The deal with the angle brackets. I don't know. I'm not a programmer. When you declare a type of a thing, it's commonly angle brackets that you use, right?
Yeah, so angle brackets are kind of
Right.
like rigid
Right. So it's just like part of that get component call is like, hey, what type of object am I looking for? And that's how you specify it.
So
Why it's an angle bracket and why it's that syntax, I don't know.
is it mostly specific?
Other stuff can use it too. Yeah,
It
there's
doesn't show
other.
up too often, but if you want to get a type of something, that's usually what you'll use.
Yeah, it's pretty uncommon. It's pretty rare. Okay, so the reason why we're not able to move right now is that the force that we're adding is way too small. So the friction between the ground and the capsule, and combined with the mass of the capsule, gravity is just basically pushing us to the ground. So we want to be able to add or multiply this movement vector by something. Now we can stick a magic number in here and just say, okay, 10, you know, it's going to be 10. And if ever we want to edit that, we're going to need to go back into the script and modify that property in this code. But Unity is way more awesome than that. We can use the same feature that Unity does when they exposed all these properties by just declaring a public variable. So at the top of the script, if you go just after the first curly bracket, you go public float, and you type in, give it a name, move speed is good. And I like to initialize things whenever I can, so I'm going to initialize this to 10. And you may have noticed that I put an F after it. That's just kind of a force of habit. Unless you declare something, like if I had 10.5 in here and I didn't have the F, Unity would be sad about it because it doesn't know how to. One of the students in the previous section actually told me why it does that, and it's because it's confused about whether it should use a float or a double, which both do the same thing but have different sort of resolution. So anyway, if you have a decimal point, you need the F. I just put it there anyway because I've run into so many situations where passed it to like an integer, and it's annoying. So force of habit. That's a float, and we're already declaring it as a float, so it's like it's a float. You know, I don't need to do it, but I can't reprogram my brain at this point. So we've got our publicly declared move speed there. We just want to take it down here and paste it into our multiplication. So it's going to take move speed and scale that movement vector by whatever that number is, right? And the great thing about this is that when we go back to Unity, the inspector is going to update, and now we have a public variable that we can change, and change during gameplay too, which is great. Yeah. Const. I don't know that I've ever used constant variables with Unity. I usually use some sort of system that has like a, you know, some sort of scriptable objects or something like that. Oh,
I mean, if
yeah.
Const, like, something you're probably going to defend.
Yeah.
Make a constant variable, they don't change.
Is that true?
I'm not sure.
I don't think I've ever, in Unity at least, I've never used constant.
So,
In the inspector, you mean?
Yeah, in the inspector. Yeah, so we do variables.
Right. So that way you can like just edit it without bringing up the script.
Yeah.
Yeah.
I think Const.
Also,
Yeah, I don't know.
so do you need to, like, when you're declaring a public variable, do you need to specify?
You need
Yeah,
to
it needs
specify your variables.
it needs the variable type
Yeah.
in there. Okay, so now I've got a bit of movement speed. It feels okay, but I want to modify some of these settings with the rigid body, such as the mass and the drag and the move speed. Here's the kind of takeaway that the recommendation I have. Unity's physics system is built to emulate real world physics, right? And that, for a lot of games, is perfect. Making an RPG, you want boxes to fall and characters to move around like they're real characters, great. If you're making something that you want to feel different, like Super Meat Boy or Mega Man or something like that, I steer as far away from the physics system as I can, because there's so many calculations between the friction of the surfaces, the mass, the drag, that are applied to your character that don't give you enough control, that do things under the hood that are counterintuitive or just difficult to interpret. I like to strip all of that away, build my own gravity, build my own, I can still use collisions, that's great, but really not rely on rigid bodies at all. But for this example, like, I think before I was playing with 25 is good for move speed. I think 0.5 is good for math, so a little bit lighter, so that should increase acceleration, super zippy. And then if we give it a drag of 10, that kind of limits our max move speed. But still feels kind of nimble. If I wanted it to feel a little less nimble, I might drop the move speed, move force, I guess it should really be. But that reduces my max move speed. So maybe I'd even like go back into my input manager and add back in the gravity and sensitivity, or at least the sensitivity. I always prefer when, you know, it's okay if a character takes a minute to get started, but when they feel like they're on ice and it takes a minute for them to stop, that's usually frustrating. So maybe I go in and change the sensitivity back down to like 5 or something like that. So game feel and player control is all about the type of experience you want to build. There's no right or wrong answer, like I said. It depends on the challenges. It depends on your design as far as the sort of emotions that you want the player to experience. But it is critical because the avatar is the thing that the player is going to be interacting with throughout the whole game, right? So if you get this wrong, you're going to end up with a pretty frustrating experience. And it just takes a lot of time, a lot of iteration, try stuff, and feel it out. And a lot of times you don't know. Like, it might feel fine here, but you throw an enemy in there, you throw a platform challenge in there, and it might suck. So as your game gets built out, you're going to go back and iterate and change your properties, change your jump height, your jump force, things like that. Max speed was controlled by drag. Another way to do max speed would be to look at the velocity of your character and say when your character has reached a certain threshold, like 25, arbitrary number, but let's say when it reaches 25, cut off input control, or at least scale the input control so it doesn't go beyond that, right?
So does drag do the same thing as what you described?
Drag is super annoying, and for a platforming game, drag applies, it doesn't apply in a frictional sense, like between two objects. It's literally like a max move speed. So it's never going to get above, even if it's falling by gravity, it's never going to get above that drag. So I could set this up to 100. It's not even going to flip and move 50. Higher numbers, more drag. This is exactly the reason why I don't like using physics. Is because I don't know. And I can't really, like, it makes some intuitive sense. Drag is not like friction, I will say that. Drag is something that Unity have come up with. It doesn't exist in the real world, but it's there. And angular drag is rotation, right? So how fast can the character turn or rotate? So anyhow, those are your basics for Unity.